Ever wondered how high you could jump on different planets, moons, or even those distant icy dwarf planets? Imagine yourself on the moon, where gravity is just a fraction of what it is on Earth. You could leap 6 times higher than you can here. But what about other places in our solar system? Gravity plays a huge role in how high we can leap. It's the force that pulls us down, and it varies greatly depending on where you are in the universe. Different worlds, from Earth to gas giants like Jupiter, have unique gravitational pulls. On Jupiter, the gravity is so strong that you would barely get off the ground, even with your best jump. Some have weaker gravity, letting you soar through the air, while others make even a small hop feel like an Olympic feat. Imagine trying to jump on Mars, where gravity is about 38% of Earth's. You'd definitely get higher, but not as much as on the Moon. Today we're taking a thrilling journey through the solar system to explore how far off the ground you could get on various celestial bodies. From the rocky surfaces of Mercury to the icy plains of Pluto, each destination offers a unique experience. We'll be talking about planets, moons, even asteroids. Each has its own gravitational signature that affects how high you can jump. So, buckle up, space cadets, because the numbers will absolutely blow your mind. Let's get started on this cosmic adventure and see just how high you can jump across the universe. Let's start with our home planet, Earth. On average, a person can jump about 1.5 feet, or half a meter. Earth's gravity is 9.8 meters per second squared. It's what keeps us grounded and makes life on Earth possible. But what if you could experience a different pull on a different world? Imagine standing on a planet with weaker gravity, feeling lighter, almost buoyant. Before we journey to those distant worlds, let's appreciate Earth's gravity, the force that connects us all. Let's blast off to Mercury! With only 38% of Earth's gravity, you'd be jumping a whole lot higher. On Mercury, you could soar about 4 feet or 1.2 meters into the air. Mercury's weaker gravity is due to its smaller size and mass. Less mass means less gravity, and less gravity means more airtime. But Mercury's surface temperatures are scorching hot, reaching 800 degrees Fahrenheit during the day. And with no atmosphere, you'd need a special suit to survive. Still, leaping tall rocks on Mercury is undeniably cool. Next up, Venus. Often called Earth's sister planet, Venus has a gravity just a smidge less than our own. On Venus, you could jump about 1.7 feet or 0.6 meters. But the real star of the show on Venus is its atmosphere, a thick blanket of carbon dioxide. The surface pressure is about 92 times greater than Earth's, like being 3,000 feet beneath the ocean's surface. So, while you might jump slightly higher, you'd feel the immense weight of that atmosphere pushing down on you. We're setting our sights on the Moon. With just 16.5% of Earth's gravity, the Moon is a low-gravity paradise. You could soar a glorious 9 feet or 2.7 meters into the air. The Moon's low gravity is due to its smaller size and mass compared to Earth. Weaker gravity equals higher jumps. This low gravity has significant implications for future lunar missions, making it easier to move around and transport heavy equipment. Neil Armstrong's words, "One small step for man, one giant leap for mankind," were scientifically accurate. Next stop, Mars. On Mars, you'd be jumping about 4 feet, or 1.2 meters high. Mars has a significantly weaker gravitational pull than Earth, about 38%. This lower gravity is a big plus for future Mars missions, making it easier to move around and carry heavier equipment. Mars is smaller than Earth and has a less dense core, creating a weaker gravitational force. Imagine bounding across the Martian plains, exploring ancient riverbeds and searching for signs of past life. With every jump, you cover more ground, your steps lighter, your spirit soaring. We're venturing into the asteroid belt to Ceres, a dwarf planet full of surprises. With a surface gravity about 3% of Earth's, you could jump an astounding 52 feet or 16 meters high. Ceres' weak gravity is due to its small size and composition of lighter materials like ice and rock. Imagine launching yourself into the air and experiencing a slow, graceful descent. Ceres is like a cosmic trampoline, just waiting for us to experience the sheer joy of weightlessness. We're taking a giant leap to Jupiter. With a gravity that's 2.5 times stronger than Earth's, you'd barely manage a jump of 0.6 feet or 0.2 meters. Jupiter is a massive planet, about 318 times more massive than Earth. While Jupiter is predominantly composed of gas, it doesn't have a solid surface like Earth. The pressure and density of the gas increase as you descend, eventually becoming so great that it would crush anything that ventured too deep. Jupiter's gravity is a testament to the incredible forces at play in our universe. After Jupiter, let's take a break on Ganymede, the largest moon in our solar system. On Ganymede, you could leap about 10 feet or 3 meters high. Ganymede's gravity is surprisingly gentle due to its composition of water ice, which is less dense than rock. This difference in density means Ganymede has a much lower overall mass, resulting in weaker gravity. Imagine yourself on Ganymede, an icy giant bathed in the pale light of Jupiter. You take a running start, feeling the crunch of ice beneath your boots, and then you leap. We're heading to Saturn. This gas giant, the sixth planet from the Sun, is known for its stunning rings made of ice and rock. Saturn is a world of wonder and mystery, with its swirling storms and majestic appearance. With a gravitational force slightly stronger than Earth's, you'd only manage a jump of about 1.4 feet or 0.4 meters. This means that despite its massive size, Saturn's gravity is not as overwhelming as one might think. But Saturn's moon, Titan, offers a completely different jumping experience. Titan is the largest of Saturn's moons and the second largest moon in our solar system. Its surface is covered with a thick layer of ice and a mysterious hazy atmosphere. On Titan, you'd be able to jump an impressive 10.8 feet or 3.3 meters. This is due to Titan's lower gravity, which is only about 1/7 of Earth's gravity. Titan's atmosphere is incredibly dense, even thicker than Earth's, which helps to slow down the rate at which objects fall. This dense atmosphere is composed mainly of nitrogen, with traces of methane and other gases. So you'd not only jump higher on Titan, but you'd also descend more slowly, making the whole experience feel like a slow-motion dream. Imagine floating gently back to the ground, almost as if you were in a low-gravity ballet. Titan is a truly unique world with lakes and rivers of liquid methane. These hydrocarbon lakes are unlike anything found on Earth, creating an alien landscape that is both fascinating and eerie. Exploring Titan would be like stepping into a science fiction novel full of surprises and wonders. We're heading to the ice giants, Uranus and Neptune. These two distant planets are often overlooked, but they hold some of the most fascinating secrets of our solar system. On Uranus, you'd manage a jump of about 1.7 feet or 0.6 meters. This is due to its lower gravity compared to Earth. Imagine bouncing around on this icy giant with its unique sideways rotation and stunning blue-green hue. On Neptune, the gravity is a bit stronger, allowing for a jump of about 1.3 feet or 0.4 meters. Neptune, with its deep blue color and fierce winds, is a world of extremes. Its atmosphere is filled with dynamic weather patterns, including the fastest winds in the solar system. But the real surprise is Neptune's moon, Triton. This moon is unlike any other in the solar system, with its retrograde orbit and icy surface. On Triton, you could soar a remarkable 19 feet or 5.8 meters into the air. This incredible leap is possible because of Triton's low gravity, which is a result of its relatively small size and composition of less dense materials. Triton's low gravity is due to its relatively small size and composition of less dense materials. This makes it an intriguing destination for future exploration, as scientists are eager to learn more about its unique characteristics. Triton is an icy world with nitrogen geysers and a retrograde orbit, making it a true oddball in our solar system. These geysers are a fascinating feature, spewing nitrogen gas into space and creating a thin atmosphere. Triton's retrograde orbit suggests it may have been captured by Neptune's gravity, adding to its mysterious allure. We're venturing to the realm of dwarf planets, Pluto and Eris. On Pluto, you could leap an astounding 25 feet or 7.6 meters into the air. Pluto's weak gravity is due to its small size and composition. Imagine launching yourself from Pluto's surface, the distant sun, a tiny point of light in the vastness of space. On Eris, you could leap about 18 feet or 5.5 meters high. Eris is slightly larger than Pluto, and its gravity is a bit stronger. These distant dwarf planets are potential havens for high-flying adventures. So there you have it, a whirlwind tour of our solar system, all through the lens of one simple question: how high can you jump? We've explored planets, moons, even dwarf planets, each with its own unique gravitational pull. Imagine soaring through the thin atmosphere of Mars, taking giant leaps across the lunar surface, or feeling the weight of a gas giant's pull. Which world would you choose for your cosmic jump? Let me know in the comments below. And don't forget to subscribe for more mind-blowing adventures through the cosmos.